That's all right. Thanks, Jerry. Hi, everyone. I'll be presenting a case study on using a compact and portable bathymetric unmanned, uncrewed surface vehicle for mapping isolated Arctic lakes for climate change research. This research was conducted by its lead scientist, Dr. David Rossi of the Water Research Institute at the Italian Center for National Research in Rome, Italy. Jerry told me not to make it salesy, so I'm going to put all the sales stuff up front so you forget by the end. But Seafloor Systems, Inc. is the company that makes the drone. I'm the founder and CEO. We're based in California, outside of Sacramento. And we've been building the Hydrolite Echo Sounder since 2005 and USVs since 2009. We have over 1,000 USVs out in the field. Seafloor uncrewed surface vehicles. I can't say unmanned anymore. So we build them from 5.5 meters all the way down to about a meter in length. So the TriDrone we have on our booth out there, Swiss Army knife of USVs, multi-payloads, payload agile. So we've put single beam echo sounders on it, ADCPs, side scan sonars. That has an autonomous capability, long endurance, non-corrosive, field repairable. EchoBoat 160, this is our most popular USV. It's two-man portable. Has a built-in sea chest where you can actually fit a multi-beam echo sounder or an ADCP or a side scan sonar. Again, also non-corrosive materials. And it has our SmartCast. So this is the first small USV of its type to actually have a launch and recovery system for a sound velocity profile, which is a critical part of doing multi-beam bathymetry. Again, we have a launch and recovery system. We have a hot swappable payload bay, and it has up to 12 hours of endurance. EchoBoat 240, similar, just a little bit bigger. I say no compromises because with the EchoBoat 160, we built the boat and then we had to find small sonars to fit inside of our small cramped boat. So with this boat, we actually found a really good, or the high-end multi-beam echo sounders like a Teledyne Reason T50 or a R2 Sonic 2024 and built the boat around it. So this is a full survey boat in a 2.5 meter form factor. Fully autonomous, has collision avoidance, extremely flexible. And then our biggest boat, the Hydrocat 550. So it's a 5.5 meter catamaran, wave adaptive. So individually articulated hulls. You can go from inshore off to offshore, autonomous, extreme payloads. We actually put a dual head multi-beam echo sounder on this unit on its retractable sonar pole. You can have multiple payloads and it's trailerable. But lastly, this presentation here is about our smallest drone called the TriDrone, also on our booth. So it's a compact, uncrewed survey vessel. So you can see extremely compact, foldable, portable. Kind of looks like the, what would you call that? The Klingon bird of prey. Pretty sure the engineer that developed it goes to these conferences dressed as a Klingon. It was actually originally developed, I kid you not, this was a good idea of one of our engineers. Let's see if we can tow a water skiing squirrel. Squirrels are hard to tame. So we've turned it into a dedicated platform surveyor. So it's evolved into really just a hydrographic survey platform. Like I said, extremely portable, maneuverable, has a real big high payload capability inside of its payload bay. And we talk about zero drag or zero offset. So most catamarans typically have a pole extending into the water, creating drag, a surface plane. We built the echo sounder into the hull, so it shoots through the hull, extremely maneuverable, and it's a swappable between a single and a dual frequency, and again, zero offset. So we actually put the antenna over the echo sounder transducer, so there's no offsets for the horizontal. So getting to what I'm here for is the project. So this is about nutrient cycling, ecosystem functioning, and climate change in the Arctic lake ecosystems. So nutrient cycling, so transferring nutrients from one medium to the other, animals to plants to the ground and back. So what's happening in the Arctic? See if I can start this video. We've got, with climate change, we've got warming, the glaciers are melting, creating these giant lakes, shallow, fishless. All the runoff creates big, big, vast lakes. So we've got barnacle geese. These are migratory lake birds, are attracted. So the barnacle goose on its annual migration stops in these lakes, does its thing, and then reindeer are drawn to the vegetation that grows on the nutrient-rich soil, which brings polar bears, Arctic foxes, ring seals, the western short-haired yeti. I just made that one up, actually. So mapping Arctic lakes north of the 79th parallel. Dr. Rossi and his team from the Center for Water Resource trekked to the Arctic to investigate how climate change is affecting the Arctic ecosystem. So we've been using drones in the Arctic. It's a pretty commonplace these days. Here, Seafloor actually deployed a USV in 2019 to the northern Greenland with Dr. Larry Mayer's team from the UNH, Center for Coastal and Ocean Mapping, NOAA, and the Swedish Maritime Agency on the Swedish icebreaker Odin for Project Ryder. Project Ryder was a research expedition to the remote Ryder Glacier in northwest Greenland on board the Swedish icebreaker Odin. By mapping the seafloor area around the glacier, researchers can find patterns and causes of historical changes in the glacier. This knowledge can help us understand how the marine cryosphere is affected by climate change. So here, the Seafloor Echo boat with an integrated multi-beam echo sounder was deployed by a helicopter from the icebreaker and ahead of the research vessel, so that the research vessel didn't run risk of running aground. So they actually lifted it with that helicopter, dropped it in the water, surveyed it. The data was broadcast back to the boat, and that way the icebreaker could actually be navigated inland. So if I go back, you can actually see the work site, northern Greenland. We were never able to access these even in the summer, but now as climate changes, it's all opening up, so now the vessels can actually get up in there and do their survey work. However, this is the first time a hydrographic USV has been used inland for mapping Arctic lakes. So here we're talking about a polar archipelago of Svalbard between mainland Norway and the North Pole, one of the world's northernmost inhabited areas. That's what I thought Norway looked like everywhere, but apparently it's not normal. So here's the area here. You can see the entire archipelago on the right is in this small area between 74 degrees and 81 degrees north latitude. The survey site consisted of a set of lakes centered around the 79th parallel. So why they chose Svalbard? So for millennia, lakes in the Arctic tundra have locked up huge loads of carbon in their sediment and in the ice. But as the Arctic becomes warmer and wetter, scientists believe these lakes could be turning into sources of carbon, which would have important consequences for the world's climate as they're released from the melting glaciers. So challenges, definitely a challenging task. And it was a daunting task, but the team of Italian scientists were definitely up for the challenge. It's a good, hardy group. So trekking up to 20 kilometers per day over the rocky and wet terrain to reach their survey site before returning to their small boat and taking them back to the camp each day. Fording rapidly rising rivers of ice melt to reach their destination, definitely a challenge. So they had a bunch of challenges, but the big threat was polar bears up there. So not only did they have to carry all their gear, they had to carry a gun. There was always that threat of polar bears in the area, and scientists were definitely cautious. I think they should give the guy that's carrying the heaviest load the gun, though. Also, on top of the environmental challenges, there was administrative challenges because the scientists had to overcome a radio silent zone where they were working. So apparently, permission to use the USV's remote controller and the GNS Bluetooth had to be requested daily and granted by the government. And again, they had a geodetic Earth observatory set up there where they were actually a network of stations to define the global geodetic reference frame, and they had to Anything between 2 and 32 gigahertz was banned. So here the Brugger Peninsula on Svalbard provided the researchers with the ideal research area owing to its multitude of fishless glacial melt lakes concentrated in an accessible location. Here we can see a kind of a map of all the survey lakes that they've got. So I think there were 23 lakes identified and marked for survey as part of the study. So the tools. With the help of HYPACK, detailed lake water volumes are measured and used to evaluate nutrient concentrations. Oops. So the TriDrone, that was ideal for this application owing to its portability, maneuverability, integrated echo sounder, and its large payload bay. Here, a small Windows tablet fit within the payload bay of the TriDrone to keep it out of the elements. We had a 10-centimeter horizontal and vertical accuracy L-band GNSS receiver, and HYPACK Echo. So HYPACK Echo is just kind of a small HYPACK package. It was loaded on the Windows tablet, and it provided the researchers with a data collection platform for the Echo Sounder and the GNSS, as well as the ability to clean and export the XYZ data to be processed to determine the lake volumes. Here are some basic specs of the USV, Echo Sounder, and GNSS antenna used for the program. Owing to the grueling daily trek to the survey site, the minimum amount of required gear could only be taken. So once the team reached the site, the system was initialized, HYPACK survey launched, and all the connections were verified, data logging was started on the system, and the USV was launched into the lake to be driven by hand to collect as much data cover as the area, over the area as possible. So originally they had planned these lines, but because the TriDrone is RC only, they had to be hand driven, but they did a pretty good job. I mean, if you look on the bottom picture, they got a lot more data than they actually originally were gonna collect. So here's a video of them actually launching the USV. You can see it's folded up. It's got a single thruster that's servo driven on the rear. And as you can see, it's extremely maneuverable because of the servo-driven thruster on the back of it. With its shallow, less than 10-centimeter draft, the TriDrone was the ideal platform for mapping these mostly shallow lakes. After each lake was surveyed with the USV, it was loaded onto the back of the researchers and then off to the next lake. And with the 2-kilometer range of the TriDrone, enabled the team to conduct their survey safely from a spot overlooking the lake. And you can see the TriDrone in the distance there with its wake. A total of 23 lakes were surveyed with this method successfully. HYPACK Echo enabled the researchers to export XYZ data to MATLAB to calculate volumes as well as planar and surface areas of the lakes to be used in their research. Another benefit of the bathymetric survey was the ability to identify drainage channels, paths of the melting glaciers, enabling the researchers to predict where future lakes will develop. Definitely plenty of photo op on this survey. So the lucky researchers conducted vital research while visiting one of the last frontiers on the planet. Here you can see a receding glacier abounded the whole research area. And here we can clearly see a receding glacier in the background with an ever-growing lake in the foreground. And again, here we have a bare post-glacial ravine, an extremely deep lake formed when it melted, releasing trapped carbon back into the ecosystem. The operation was a success. All of the required data was collected, gathered, and processed to use in the research. Doctors Rossi, Salvatore, and Caliza, accompanied by their graduate research assistant, Sophia, pictured here. And thank you to Dr. Rossi for sharing his research and his presentation and the media with us. The end. Thank you. Any questions? Small, yeah, 1 foot or less for sure. Absolutely, it's extremely wide and, you know, very stable. Yep.
I came a little bit late, but did you guys camp while doing all this stuff?
No, they did not camp. They would take a bus to a boat and then a boat to their sites, and then they would trek up to 20 kilometers each day to and from the site. Yeah, it's pretty cool.
How much does the TriDrone weigh? How heavy is it?
Without any payload, like a tablet or anything like that, it weighs about 8 kilos, so about 15 pounds. Yeah, not too bad. Yeah. Yep. Sorry? The L-band, I can go back and tell you which one it was. Let's go back to the site with the gear. Microgeo? So they're using satellite-derived corrections. I'm sure it's post-processed, yeah. But I mean, 10 centimeters, I'm pretty sure they can get that real time. Runer, I'll have Dr. Rossi call you and work it out with you. Any other questions? Yep.
With the temperatures, were there any problems with the thruster freezing up or any ill effects on battery power?
Nope, they did not have any issues at all. Yeah, typically the batteries don't like the cold weather, but they seem to do really well. No issues. Anyone else?
With this small system, did you have an autocast for some
We did not. We did not. No. I think they just estimated sound velocity based on the temperature and the depth. Yeah. Yeah. It's not for navigational purposes, the data, so I don't think they were super concerned. Yeah. Thank you.